Hi everyone, my name is Bharath Kumar and I am honored to present to you at TestFlix. Quick introduction about myself. I currently work at ThoughtWorks India. I lead the QA community there, and I also lead operations for the data and AI service line at ThoughtWorks India as well. Today my topic is going to be about streamlining data quality assurance. I'll talk a little bit about what data quality is, why it is important, how we measure or quantify data quality using dimensions, how we can use these dimensions and assign quality objectives or service level objectives to these dimensions, and creating our first automation script using the library Great Expectations. So why is data quality important? Given the status of data today in the world of IT, uh, it is extremely important to make sure that the data that we are ingesting, storing, processing is of the highest quality, because ultimately uh, the data has to meet the needs of the user or the use case, or the business that is planning to use this to either make decisions, train AI ML algorithms, which are going to be the core or the bedrock of business going forward, or create a system by which you have trust in a system in terms of what is being stored or being used, so that the outcomes that applications have based on the data that is stored or being processed is there are no questions around it. An example of why data quality is so important is because of the impact that improving data quality has on an application. So, in a recent talk by Andrew Ng, who's an expert in the field of artificial intelligence and machine learning, he gave an example of how to improve or what really has helped improve the quality of ML software that is being used to, let's say, detect defects in steel production. And he mentioned that despite engineers working on the models and the algorithms and trying to improve them, there was literally 0% improvement in the outcome of the application. Whereas making sure that the quality of the data that was used to train the application or use the application's testing data uh, provided huge improvements in the outcomes of the application, in terms of less bias, in terms of the outcomes that are expected, etc. So looking at data quality is extremely important. But before we can, make any improvements to our system, we need to understand what the status quo of our system is. We need to be able to measure or quantify the quality of the system that we are currently looking at. And the way that we typically do this is through attributes or through dimensions, such as the ones that you see in the Venn diagram to the right. There are these are a limited set of attributes. There are a lot more attributes depending on the technology that you use, the data, the use case that you have, or the type of work that you're doing with the data. However, the most common data quality dimensions that are universally used across projects are typically these six. The first being the freshness or the timeliness of data, which relates to the time bound data that you have. So for example, if you're creating a report for the previous quarter, any data that does not exist from that particular quarter is meaningless or is harmful to the creation of business insights for that report. So the freshness or the timeliness of the data that you have to measure is extremely important. The second is completeness. So let's take an example of uh, a common customer. So 10 years, 15 years back in India, nobody had an Aadhaar card number, or very few people used to have it. So it was not necessarily a required field for people to fill in applications for loans, etc. However, today it is a required field and something that is needed by anyone that is planning to use or planning to fill out an application, for example. So if people are planning to use data over a period of time, and there are issues with the completeness of certain fields or data within that field, it could cause issues with the outcome of that data. Similarly, consistency. So consistency is a measure of how close or how equal the destination data for a system is to its source data. So when we pull data from different sources, we do a number of transformations, anonymizations, cleaning to them. We might even do aggregations, etc., which would transform the data from its initial format. However, we need to make sure that the truth of the source data does not get compromised when we do all of these transformations on the data. That is what consistency measures. Accuracy is the accuracy of the data fields themselves. A good example would be to take a look at an email field, for example. So there is a standard format for an email. So when you're pulling in data that has an email, you might want to make sure that the accuracy of the data with respect to the format of the email or a telephone number, for example, holds up and that it makes sense. The next is the validity of data or the conformance of data to business rules. So an address, for example, in most countries would have a particular format. And for it to be acceptable, in India, for example, you would need to have a state, you would need to have a PIN code, an address line 1, address line 2, sometimes which is optional, a house number, which are all data that is typically collected to form an address. Other examples could include having data only from a certain list. So for example, if you have a gym membership, you could have a gold membership, silver membership, bronze membership. And these are business rules that define what membership means for this particular business. Any data that is outside of the bounds of these examples would not make sense to the business. The last is uniqueness of data. So uniqueness of data in a customer record, for example, would be a transaction ID. The transaction ID should be unique so that that particular transaction can be identified at any point in time. So these six are typically the most important ones that are collected across most projects. Of course, the thing that most defines which attributes are more important or which attributes are the most important, maybe including the ones that we talked about, over and above the ones that we talked about, such as the discoverability of data, for example, would depend on the use of the data, what the business case is, what the use scenario is, etc. What the governance policies of the organization or even the country that it's operating in, for example. And of course, the technology stack that is used to store or use that particular data. So now that we've talked about measures, how do we really define targets to these? So the reason that it's very important to look at what we call service level objectives is that we need to set a clear target or clear goal as to how data quality needs to be measured in a particular system. So data quality is typically measured using service level objectives that are set by a team or the primary stakeholders who govern or who are accountable for the ownership of a particular project. So they are the ones who would say, let's say there should be 100% uniqueness, let's say on the customer ID field. There should be at least 90% completion of data if it can be used, let's say for training a machine learning algorithm, for example. However, the most important aspect of a service level objective is that it sets clear expectations between stakeholders in terms of what you can expect from the data that you are using. So let's take an example to illustrate this case. So here's a customer record database with certain fields that are attached to them. So if we were to assign service level objectives to these, a great service level objective for consistency or would be to make sure that the source data, which is probably providing all of these, is the same as the destination data, that nothing gets changed. If there's anonymization, let's say on an ID of a customer, that should reflect correctly. For an accuracy, the email address, as we talked about, should be of a certain format and match that particular format. And there are service level objectives for each and every attribute that we can track over here. What this will ultimately look like is, providing a dashboard such as these. So there are a number of commercial tools, commercial reporting tools, etc., that would enable you to create dashboards such as these. In fact, you can even create these in Excel if you are collating the data quality reports, through some form of system. But the ultimate goal is that you're able to centralize the quantification or the service level objectives that you have with respect to the attributes that you're looking at. So in this case, the data quality is not very good because there is very little completeness, there's very little consistency, although the validity of data or the conformance to business rules seems to be okay. You need to have a track record of this data to make sure that at all points in time, the data is good quality and that you can track any issues related to, data quality getting worse or there being any issues with the data that you're collecting. So we've talked a lot about, data quality, testing and how to go about doing so. So the testing actually happens on the service level objectives that we defined a little bit earlier. And the way to automate this is through the use of libraries such as the ones over here. So I primarily focused on open source or compared open source libraries over here. The choice of library is completely up to you. If you prefer a more visual interface, Data Wrangler or Talent would be a great choice. If you like coding and if you like getting into the nitty-gritty of things, Great Expectations or Data Quality Framework or DQ are wonderful choices to use. Of course, it also depends upon how good you are with programming, how much the team, subscribes to the programming languages that you like to work with. So I'm going to use Great Expectations. So the Great Expectations library is a Python-based library, which provides you with a way of setting up a project where you can provide expectations or rules against which you would determine the quality of your data. So when you have a data set, the first thing that you would want to do is download and install the Great Expectations library if you're planning to use that. But before that, let's take a look at the overall framework of this library. So this framework primarily has two big objects or two big concepts. The first concept is that of a data context. So the data context from a Great Expectations perspective is a collection of metadata or data that enables you to configure the environment, allows you to configure the data sources, and also provides you with a programming interface for you to be able to define your expectations, run your validations, and export the output into a format of your library. It also contains all the metadata for all your libraries, so you can separate, your expectations or your rules from the validations, and keep everything separate. So it makes it very scalable. The second concept is that of a data store. The data store is basically a collection of all your data sources and all the assets that you need in order to be able to run your validations. The fact that this is completely integratable with any CI/CD software makes it a great choice in order to be able to automate and run this on a regular basis. So as I mentioned, the first part of using this particular library is to install it and import it into the class that you would like. We are going to create a data context. In this particular case, we're just creating a data context. It is not necessarily related to a set of data context that you have created. Once you do that, you would then point it to the data source, which you would like it to run your validations against. You can create the expectations or you can pull them from a file. If you were to connect to a data context with all of this information, it will automatically pick this up. Or you can override or write extra expectations or rules in order to validate your data. Run your validations and save the validations to an output file. Here's an example of a data context file, which is a YAML file that you can create for Great Expectations. Please do look at the library to understand these concepts a little bit more. But to sum up what this does, it contains all the configurations that are required for you to be able to run your script. This is an example of the sample data that we used. This is how you would create a Great Expectations file to run against that particular code. So as you can see in the beginning, I've imported the required libraries. I've connected to my data set. I've provided a path to the data context, which contains all the configurations, created all the rules that I want my validations to be done against the data, run the validations and exported it to a file. So in the interest of time, if you would like to connect with me, I'm happy to walk you through this, in more detail. Please do look out for me on LinkedIn. But in the meantime, happy testing. I hope that you guys have a wonderful day.